Everyone, sorry, we paused there briefly for a moment. Everyone, welcome to this special manufacturing hub on a Monday morning. If you are anywhere in the continental North or South America, and a semi-reasonable time if you guys are over in Europe, as Andreas is. And we will go ahead and introduce him to the show in just a moment. Again, everyone, welcome to Manufacturing Hub. Super excited to have this special Monday morning stream. You guys can wake up, listen to some technical talks, and drink some coffee, or if you're Caleb, drink some Diet Coke with us. So this is Manufacturing Hub, episode 257. We have Siemens on. We're talking all about the ProveIt session that they had a couple of months ago at the ProveIt conference. We're going to go get into their solutions. We're going to go talk architectures. We're going to go talk about data modeling and data orchestration. And knowing Caleb, we will undoubtedly talk about Rust and maybe tractors at some point.
Maybe.
Which I am super excited for. If you guys are new here, welcome. If you've been here before, welcome back. If you guys are new here, myself, Dave, and this guy up here, Vlad, every week, twice this week, get together and we talk all to practitioners in manufacturing and industrial. If you guys have questions or comments, please feel free to go ahead and throw them in the chat. Our top place that people are chatting is going to be on LinkedIn, and our second place is going to be on YouTube. So if you have somehow managed to find us in a place that is not LinkedIn or YouTube, please go ahead and check the links and come say hi and chat in and amongst that. Without further ado, everyone officially welcome to Manufacturing Hub. This is episode 257. My name is Dave. This guy up here is Vlad. And we'd like to welcome Caleb and Andreas from the greater Siemens ecosystem onto Manufacturing Hub today. Welcome, guys.
Hi.
Gentlemen, thank you so much for taking the time. I think it's going to be a very interesting conversation. I personally, as I have mentioned in one of my posts on LinkedIn, have not deployed WinCC OA, so I'm looking forward to the conversation, looking forward to understanding a little bit better as to the platform and ultimately discussing the session that you have delivered at ProveIt. But before we get into that, could I please ask both of you, let's start with Andreas first, for an introduction for those who may not be familiar with each one of you. Andreas, so how did you get started in the industrial space? How did you get into manufacturing? What was your career progression like, and ultimately what it is that you are doing today?
Yeah, thank you very much, first of all, for having me. And I think if I will start, when I started my career, then maybe we do not have enough time for that, because I'm already damn old. So I started my career, I mean, maybe 30 plus years ago, also already at ETM. And maybe for those who don't know, ETM is the company where we are making WinCC open architecture, a product of Siemens, so it belongs fully to Siemens. And yeah, I said I started for a long time ago. It's at ETM. First of all, yeah, as an IT guy, and I still say I'm an IT guy, yeah, and I have to do some job with OT stuff. And I started my career at ETM with, at those days, I think it was named P4SS, which was then renamed to WinCC Open Architecture when we got acquired from Siemens, right? And yeah, and I started with Oracle, so I was an Oracle database specialist for a long time, building Oracle clusters for our customers all over the world. And obviously, of course, also always together with our SCADA platform, WinCC OA. And that was also for me really cool, because I came from an IT school, yeah, and it was only about IT databases, maybe a little bit boring. But when you then start with the OT stuff, connecting things to SCADA, and then you start to control machines, that was somehow fascinating for me. Yeah? And yeah, and then I went through a lot of different departments, let's say development, consulting, project management, product development, and then I shifted for 6 years directly to Siemens, to the headquarters. And there I was responsible for also driving innovation for our SCADA HMI platforms. So not only WinCC Open Architecture, also for WinCC Unified. And yeah, that was for 6 years, I think. And now I'm more or less, let's say, back at ETM as the Chief Innovation Officer at ETM. And yeah, so that was a very compressed story, let's say.
Perfect. Appreciate that. I'll probably have some follow-ups for you, but let's get Caleb on stage. Caleb, could you give us an overview of your background?
Hi. So my background is such that I actually get offended if I get called an IT guy. By the way, my background is, I would say, generally speaking, OT. Um, so I have a Cisco certification, but all of my practical experience with networking is OT networking, though I did work in some industries where it actually went up to layer 3 routing and things like that. So it wasn't just some of the, I'd call it the, the semi-flat networks or layer 2 networks that you typically find in OT. My background is kind of 50% sort of embedded software engineering and product development, and about 50% controls engineering and networking in an OT context. Sprinkled in there is some stuff with IT. Increasingly, my title now is Field CTO Americas for Siemens. I'm agnostic to business unit. I'm agnostic to product, and I get to pick the products I like. One of which is open architecture. That's just the way. It's just the way I'm built, I guess. It's a good product, but increasingly I am more and more focused on agentic engineering workflows. So AI relates to engineering, and AI's relationship in an operations context to control systems and operators on the floor. So kind of both sides of where you're starting to see more and more usage of artificial intelligence, particularly we're talking about large language models, larger reasoning models kind of right now. So.
Mm-hmm. Well, let me ask both of you, I guess, a question. So for those who may not be particularly familiar specifically with WinCC open architecture, WinCC OA, could you give maybe a definition, right? And where do those lines kind of blur when it comes to SCADA, HMI, MES, right? Like, what is it used for? Again, I know that we're going to dive a little bit deeper into discussing the ProveIt session, but I think that context is important, specifically when it comes to WinCC OA.
Yeah, I mean that is not that easy to answer, to be honest, because first of all, WinCC OA is already at the market for also 30 plus years. Yeah. So it started as a SCADA platform, but the interesting thing is we already started at 30 years ago to build the platform really on a microservice-based architecture. So we have managers connecting together, and all of them are communicating via TCP/IP, and that means also you can distribute it. Yeah, and you can distribute it on different machines and connecting a lot of systems, also multiple systems together. So it is also highly scalable and distributable. But the interesting thing is also it also runs on a Raspberry Pi. And imagine that, yeah, it is a full-blown SCADA system running on a Raspberry Pi, yeah, because we've built it in C++. Even, yeah, Caleb maybe is also, I don't know, he's more the fan of Rust. I'm also not the biggest fan of C++, but it's still, yeah, for that kind of use case, it fits perfectly. And yeah, that is really crazy. And I would also say, it is not really a SCADA system anymore. I mean, it is still a SCADA system, but much more. Yeah? It is also tell it as an IIoT platform, because nowadays, if people hear SCADA, maybe they think about this monolithic old things. Yeah? It's definitely not that kind of SCADA system. Yeah?
Gotcha. Let me maybe refine that question for Caleb a little bit, right? So if I'm looking at the Siemens portfolio, and of course the broader Siemens, it obviously makes a whole lot of products from trains to transformers, but keeping it within the context of, let's say, Siemens WinCC Unified and perhaps IIH, right? If we're talking about some of the other tools, when would you pick WinCC OA as opposed to some of those other platforms? Like, putting yourself maybe in the shoes of the customer, when would you advise them to go with OA versus some of the other offerings?
I will tell you what I do tell customers, generally speaking. So for me, if it's an HMI panel, like a unified comfort panel, I obviously like WinCC Unified for that. If it's a facility-wide data, integration, orchestration, movement of data between the devices on the floor and the rest of systems, somewhat like consider it somewhat like a Kepler, I would use OA in that context, especially if I want the extra alarm management and other capabilities. I'll even use it to do things like feed ignition, as basically the Kepler replacement, but it's also very good in a lot of other scenarios as well. IIH, it's part of industrial edge. Use it for the edge. It's an edge platform. I don't like using IIH at the facility level. I don't like using WinCC Unified at the facility level. There's because I like a separation of concerns. So TIA Portal is used to engineer WinCC Unified. WinCC Unified is best engineered when you're engineering the PLC, and it is the Siemens PLC in the same environment. Phenomenal usage of WinCC Unified. If I'm not engineering a Siemens PLC in that same environment, or it's a context where the whole facility runs on this thing, and I can't have it like compile or anything like that, I need runtime engineering, that's where OA takes it up. So that's how I see the trifecta of those three products and how they fit together.
Interesting. I like that. And I think that transitions us very well to the ProveIt challenge, right? Because ultimately the question was around utilizing industrial data within, I guess, as a brief reminder for those that have maybe forgotten the challenge for ProveIt, you had a repository of data via a UNS basically broker that you could ingest and then transform, analyze, and ultimately create either dashboards or views for in order to present for better business decisions, right? And so I think it makes sense what you're saying, because ultimately there were no PLCs involved. It was just raw data collected from a facility. So again, the what you just mentioned makes complete sense. So maybe Andreas and Caleb, I'll let you set the stage a little bit as to what the challenge involved for the listeners that may not have seen your presentation on stage. I'm not sure if it's even been published yet, but could you explain to us what was your original approach, Caleb? And ultimately, I think we can share some slides as well to help on that side.
Yeah. I mean, first of all, I would also like to say that again, same what we also said at the ProveIt on stage. So we have an engineering tool, which is let's say the classic engineering tool, which is similar to other engineering tools, which has been on the market also for a long time. And it is, Walker Reynolds is saying that sometimes in a way like it is made by engineers for engineers, right? And what we now bring up very soon is a complete new way of being able to engineer WinCC open architecture. So we call it currently Engineering 5.0. And this now is a complete, I would say, game changer, a complete new way how to engineer WinCC OA, fully web-based, first of all. And obviously we do that now with AI. So now really everyone can configure WinCC OA just with prompting. And yeah, we showcase that at the ProveIt on the stage, first of all. I hope we can see my slides now, yeah. So we started to connect to the UNS, connecting to MQTT, which is really pretty easy and gets very seamless with WinCC open architecture. And then we are getting the data, we are collecting the data from the MQTT broker. And then also again, already with AI, we can say, hey, my large language model, please analyze what kind of data do we have in the MQTT broker. Yeah? And yeah, I'm always also saying MQTT is really cool. Yeah, it is data agnostic, but this is on the one hand side, it is very cool and great because you can use it for any kind of use case, let's say. But on the other hand side, it is always also hard, or maybe sometimes hard, to figure out what kind of data lives in the broker, because it is data agnostic. Yeah? And here also large language models can support us very well by analyzing the data of the tree, of the MQTT tree. And also it can give us a proposal how to create then the structured data types in WinCC open architecture. So then we transform the data from the MQTT to structured object types, user-defined data types. And then it can also automatically create these data points and data types. So user-defined data types. In WinCC OA, we say data point types, but doesn't matter. It is doing that automatically for you. And then also connecting it to the MQTT broker, right? So this is really can be done now by pressing some buttons or doing some prompts. So that was the first thing, what we showed really live on stage. And then, of course, the second thing, once when you have the data, because WinCC OA is an IoT platform, plus also an historian integrated in the system, so we can then, again, with just pressing some buttons in the new engineering environment to say, okay, and also interestingly, also the large language model already gives us hints to say, okay, this and that MQTT topics, what we have now in WinCC OA, are potentially things what you want to archive, and it gives us a proposal, what makes sense to have a history of, and then we are just pressing a button, and then we have it archived in our database, in our historian. We also showed that, and then building dashboards with this new engineering tool. Also, again, via prompting, this can be done. We can also potentially upload documents. So if you have a device where you have a documentation, a PDF, give this also to the large language model, plus the MQTT, or necessarily it must not be MQTT data. We have also shown how to connect a third-party device, for example, via Modbus, Modbus TCP. Then we can also give the documentation, giving the connectivity, the connection to the Modbus device. And then it can, again, also automatically create the devices then in a structured way in WinCC OA. And then we have shown building dashboards with that. And that really live on stage. And it really pretty worked well. So it was really cool.
Let me ask you maybe a side question, right? So in a typical deployment, I would argue, I guess, like most customers don't already have a pre-staged UNS server. So my assumption is WinCC OA in a general deployment would talk to your PLCs and get some of that raw data into like being deployed on a server, right? And I guess like the follow-up question also is when you talk about the development of screens, you mentioned it can be now done with AI, but I'm assuming there's a traditional way to also lay out some of those environments. I think Caleb had shown me the tank configuration at ProveIt. I'm assuming some of that can still be done in a more traditional way, similar to what you would use in like WinCC Unified. Could you maybe like paint some of that picture as well?
Yeah, absolutely. I mean, our new engineering tool is, I would say, it's on top of the existing one, So you can all the time also still use the classic one if you want to name it like that. So that's of course always possible. And that still will be there, because we have a lot of customers who have built tons of applications based on our classic engineering tool. And still also, to be honest, I still think there are use cases where a web is not the best thing to use. So there are still use cases out there where you want to have a native classic user interface. Also imagine as said, we are also dealing with a lot of big and distributed systems. Sometimes you're walking into the control room and you have 20, 30 big screens connected all together. I would say for that, web is maybe not the best way to go.
Makes sense. Thank you. Caleb, any thoughts on your side?
As it relates to the question, or as it relates to what I talked about during the presentation?
Well, I would say probably mostly to the slide, right? So what problems did you solve?
Well, specifically the problems that we solved were, we knew that the WinCC OA team was going to give a very product-oriented pitch, right? So, and we knew they were also going to solve the basic, what they mean by proving it, which is essentially, being able to produce some value to the unified namespace for a customer, and then maybe some direct customer value as well. So the WinCC OA specifically is really good at the common name service as being able to query the namespace. I know other products consider it an actual feature, but it's so endemic to WinCC OA, they don't even bother to call it out because it's just part of it, the fact that you can query the entire namespace. And that's a big deal for some people, but WinCC OA can just do it. So that's just a thing it does. I would say, we showed off basically an application of what you can do with it, create customer value specifically as it relates to the operational authority thing, which we'll probably cover later. But one thing that was very interesting, I'd say, is some commentary. Is a couple times I received comments from people asking about the presentation that the ETM team gave. They actually had thought that the project had been pre-configured and that they were just going through the screens, because WinCC OA is so fast that it was actually self-configuring. They were configuring a blank project. So if you actually go back and look at that video and you think to yourself, everything that I see on here did not exist when they opened it up on stage. That's one of the things that everything was happening so fast because of what Andreas mentioned earlier. It is a big deal and does need to be pointed out. I tell people all the time, I don't think very many people follow this advice, but I would, as someone who has built many, many products, always ask what language it was written in. It's not a 100% tell-all, but there are some things you can know. And the fact that WinCC OA is C++ all the way down, and that they were able to test it under load throughout its entire development lifecycle, through the close partnership with the Large Hadron Collider, it is crazy how well they've been able to maintain the performance and even improve the performance over time, despite adding new features every release cycle. So that's very, very hard to do. So it's one of the things I really truly like about it. When you demonstrate it, though, it actually causes a problem because it's so fast that it's hard for people to see what's happening, or whether or not what's happening is happening right now, or whether it was pre-configured before or what.
That is really interesting to hear. I also have heard that some people thought that it was a recording or so. So maybe next time we should add that something bad happens to see really that it is live.
Put some have WinCC OA, do some weights on the timer so that it can it just creates some latency so people can react to things in time.
Yeah, I mean, it was also a little bit a problem because we wanted to show so many things and so many cool features, and so it was not that much time. Yeah, so we have to hurry up as well.
Absolutely. Let me jump in and ask a couple of questions. My listening to you talk about everything that you covered, Andreas, my first thought is, wow, you guys covered so much in just a portion of the ProveIt session, right? Just pulling the data in and contextualizing it into WinCC OA before you gave it to Caleb and his team, or before you shared the stage with Caleb and his team. I guess two questions. One, is there a place that people can go watch the entire ProveIt session? Do you guys know if that video is live and public yet, or is that something we should follow up with you after the show?
It's not yet.
Okay.
It seemed like it was, as far as like last time I looked, they didn't yet have ours posted internally in the portal that we can get to, and we didn't record ourselves. They record it, using their equipment. So I was just recently told that maybe it's up there now. The short answer is people cannot go see it right now, but I really want them to be able to as soon as we can now. So.
Absolutely. We will follow up with you guys, and when that is available, we will go ahead and link it for all of the listeners. Andreas?
Yeah, maybe one thing I forgot
Yes, please.
to mention before, because we not only were getting data from the UNS, from the existing MQTT broker, as that we also configured on the stage really a new device, a Modbus device, and we integrated it also to WinCC Open Architecture. And then we also published that back to the UNS. This is also can be done very easily. Yeah? And also, I want to highlight here also that we have some kind of a also data modeler, let's say, where you can, first of all, you create all your machines, you connect it to the field, yeah. But then on top of that, you can model one or multiple views on the same data, yeah. And the view is a hierarchically structured data model, yeah. So you can build also multiple models, which can't be done in MQTT, yeah. But anyhow, and then you can choose the root node of this model and say, now publish that back to the UNS and plug it into a UNS on a node. Yeah, this can also be done very quickly and fast. That's also nice to see.
Absolutely.
There's a funny thing about ETM, by the way. They didn't yet have the Modbus map or anything for the device until after the recording, until after the presentation had started. So part of the design. So if you've ever configured Modbus device, Modbus master for a Modbus device, you did not know the type of Modbus it was, and you hadn't yet pulled its register map. Imagine doing it in front of a whole bunch of people live on stage. That's what they did.
Probably not a choice I would make, but I commend you and the team for going and making that choice. Andreas, you had mentioned a couple of things that I want to dig into a little bit more before we talk about Caleb and what he was doing. But you had mentioned Engineering 5.0 and you had mentioned AI prompts. Is Engineering 5.0 the ability to go ahead and prompt into WinCC OA? Or I guess, can you walk us through Engineering 5.0, please?
I mean, it's all together. It's not only about prompting. It is also not only prompting like you do in Cloud Code or so. So it is really still an engineering environment, so that you really can also see the impact of the prompts and what the large language models are doing. And so it's somehow a combination, web-based, new dashboard visualization capabilities, plus this engineering based on LLMs, and also MCP server is also included there. And also the interesting thing is here, all of this is possible because WinCC is open architecture, right? So in theory, such things, and also we see this really out in the market, that our clever ones, the clever distributors, yeah, they are also building cool and fancy things based on LLMs and connecting it together to WinCC Open Architecture because it is so open. Yeah? And also recently we added this Node.js manager, and with that done, you can now build your business logic with Node.js, JavaScript. Yeah? Okay. Python will also come soon, maybe for Caleb. Maybe there will be a Rust interface for the time. Let's see. I also would love to see it.
I'm fighting that. I'm fighting that exact thing right now. The C++ northbound API to Rust bindings.
Yeah, I think I already started with it, Caleb, but I did not found enough time to finish it. So stay tuned.
Okay, I love this. If we've got some more time after, I would like to maybe dig a little bit more into Engineering 5.0. But Caleb, I wanted to come over to you. So Andreas and the ETM team with WinCC OA, they went and they built all of this foundational work. They connected to the UNS. They built in Modbus, published back into the namespace. And then you came up, or you and your team came up, and you guys were talking about model orchestration. Can you maybe tell us, one, first, what model orchestration is, define it for our listeners, and two, kind of share what you guys did, your portion of the presentation, please.
And I said model orchestration. I should sharpen it a little bit and actually call it actor orchestration, because it's not just about models. Basically, if you said that a control system runs and a control system runs, except for the occasional time when hopefully a senior operator is maybe adjusting a set point or something to either because of something that they've seen or something that they know. That has been how it's been for as long as we can remember, except for things like MPC, APC, and that's another sort of note when I say actor orchestration. So now we come to a time where, with the rise of LLMs that are easier for people, types of AI that are easier for people to implement and deploy, the problem comes that you now have not just a single actor on the system at a given time, but you now have multiple actors on that same system, perhaps even on the same valve or drive set point. So the question is how do you coordinate between these actors? How does a AI model in the cloud that's writing to a set point on a machine, how does it know if an operator has placed the machine into manual mode and is currently jogging that drive? How does, if you have 4 AI models, like an autonomous vehicle, for example, has hundreds of AI models running in it. If we had 4 running in a factory, which it would be more than that if you really wanted to do it, how do they orchestrate together on either the same machine or machines that are independent on each other, right? So if they're both operating on the same line, or they're both operating on the same machine, how do you orchestrate that together and with the operator? So what we showed was the idea that you do have multiple actors on the system. In this case, we demonstrated an operator, an LLM. This case, it was Claude, and thirdly was ZPAT, which is a product. So the use case we use is pharmaceuticals. We modeled a bioreactor, and we modeled it because one thing they don't tell you about ProveIt is that ProveIt, they're just playing a recording. So anything you do to the system, you won't actually see an impact. So what we did was, on our side, is we simulated a bioreactor using a Siemens product called Simit, which wasn't part of our solution. It was just Siemens having to make simulation software as well. So and that allowed us to then see the impact of our commands, see how the bioreactor respond, which was an important element to what we were trying to show. And we have another product called ZPAT.
Oh, he's gone.
It happens. Let's see here. Should be back in a moment. There we go.
Okay.
Can you hear me all right?
Yes, sir.
Oh, where'd you lose me?
You have another product called ZPAC, you said?
So ZPAT, basically what that is that is a product that uses process analytical technology that basically measures cell growth within the bioreactor and then tells you if things are going well in there. Because those are long form batches, and if you lose the batch anytime in, then it's a lot of money. So what it does is it tells you if the batch is going well in terms of looking at the primary value, which was essentially cell growth inside the bioreactor. ZPAT does this through the use of what they call a hybrid model, which is basically modeling a digital twin of the bioreactor. And then you can then write back to adjust the set point based off of what it's seeing, right? So that is an actor on the system. It's not an AI model, but it is an actor on the system that is neither the operator nor an AI model. It's why this is why we talk about the importance of being able to coordinate between things. But it is acting on the system, and it inherently does not know whether or not the system is being acted upon by something else. So now when you inject the operator at the bioreactor and you inject an LLM that's writing the set points through WinCC OA, you have to ask yourself how you're going to coordinate those 3 entities. And so that's what we demonstrated, was showing that off, basically. We demonstrated solving a real problem. So by leveraging ZPAT plus WinCC OA together, we were able to impact the dollars and cents for a pharmaceutical customer who's trying to do what they call real-time release testing. very pharma term, so I won't go too further into that. But in my mind, more importantly, because it's less well understood or appreciated, which is the fact that the moment that you start doing that, everybody likes to focus on use cases, and I hear that all the time, but the moment you start doing it, there's a very real implication requiring a very real different type of architecture or different type of system. And it's only going to get worse as time goes on. As you have more actors on the system, that problem's going to compound. If you don't solve it now, it's going to be a lot harder to solve later on. You're going to have kind of a mess on your hands. So that's what we were trying to get out ahead of.
Let me, Caleb, maybe ask you a follow-up, but ultimately take a step back right now that I'm maybe also understanding the magnitude and the complexity of the approach, right? At least with my current customers and conversations, there's a lot of, how would I say it, slow-moving pieces where LLMs are to an extent being queried against the data, but ultimately it's the human that's going to make any adjustments or changes. And my understanding, again, having a more, I would say, like food and bev and CPG background, in pharma, it's even more so constrained for those specific use cases, right? So you're describing a situation where maybe in parallel in the past we had PIDs to an extent like fighting different areas of the process, but in this case it's different agents trying to actively make changes on specific process variables. But I'm assuming there's still certain guardrails, or could you explain maybe what you're seeing in the current systems, but also, as I'm sure maybe some of the listeners get not necessarily paranoid, right, but are trying to figure out like what can we allow the LLM to make changes on versus be a little bit more conservative on. Could you paint us a general picture of where the industry stands and how do these agents currently make some of those decisions with or without humans?
So I'm going to say that the problem for controls engineers now is that if in my experience, I always see people from, I'll say it, maybe is sometimes manager, but generally speaking, VP up. To the vice president up of a company, they seem to want to go and hammer AI into all parts of the business, right?
Sure.
So
yep.
As a controls engineer, it's getting harder and harder to just say no. You can't use it, right? So in a lot of ways, what I'm doing is what we're trying to do is help the controls engineer, because we know that it's not going to happen by magic. You're not going to be able to safely have AI write to control systems just one day. It's going to work, and it's going to be something you can trust. It's going to be, you've worked out the process by which it works, etc. But as it is today, you're receiving an increasing number of pressure, and it's going to eventually start affecting your job if you don't figure out, instead of just telling the executive, no, we can't do it right now or whatever. Eventually, you're going to have to say, okay, here's how. We'll do it safely. So anyone who's thinking about like, oh, well, of course, I would never actually have a write directly to the system, and I would have the operators sit in the middle of it and everything. Of course, it's a part of the progression. But does anybody think that's the end state? How long? How long of that happening successfully before you would not have the operator be part of that, right? That's a question we have to ask ourselves.
Yeah.
In order to get there, we have to hypothesize as to what that architecture would look in its end state, and then build to that. If we don't understand what good looks like, or if we don't understand how that happens, especially as AI evolves, because one of the things is, if we had this conversation before, which we might have had it in episode 145 or whatever was, since then the conversation would be dramatically different, just because of it seems like it's nearly weekly shipping being done by the LLM providers right now. They just shipped they all just shipped another variant last week.
Yep.
I think Claude Opus is now on 4.7.
Yep.
OpenAI is now on 5.4, and
5.5.
So again, 5.5. Thank you. That's not where we were 2 weeks ago, or it's not where we're ProveIt even, right? So this conversation around when will LLMs be ready changes every week, and in my view, the window closes further and further every week, where basically, without having this conversation or understanding the process by which we would even validate whether or not it was the right time to do it, because no one can argue that if it were able to do it consistently that good, just the fact that it can watch without getting tired 24 hours a day means that you will see business improvement the moment you can trust it. So the question becomes, how do we validate whether or not we can trust it? And of course, part of that process is having the LLM write the set point that it desires to a human. But a lot of the problems that it's designed to solve. This is kind of an interesting. I don't want to get too theoretical, philosophical here. But one of the problems that this causes is now you have to ask yourself, well, why did they want the AI to write the set points at all if we could always trust the operator to make the right decision? The answer is almost every company I've talked to said that their process runs better when it's like a senior or like their first shift operator than if it's their second or third shift.
Of course.
So they already don't trust 2/3 of their operators, right? So now what? We're having the operator on third shift who we didn't trust, and why we had the LLM assessing whether or not the LLM is giving you the right answer. Or we do know for a fact that LLMs are pretty creative. And so there are some solutions they'll come up with that won't be understandable to a human who was just staring at it, running in a particular way for the last 15 years. And I've seen that become a problem. Like I've seen issues where they won't make a change even though they knew the sensor drifted, because like it's so this becomes a very difficult question to answer, right? Yes, a pat answer would be that as part of the workflow, as part of the evolution of what you're doing, you would follow the you could say we could follow the levels of AI coding. So if you say what are the levels of AI coding, there's an equivalent level of AI operations. In AI coding, there's 5 levels. 2 is what they call spicy autocomplete. Like 4 is when the agent is basically doing all the development and the coder is just reviewing it. 5 is the AI is both doing the development and the review, and the developer is just writing the tests and writing the specs, right? So we said, what is that? We could follow the same level. Level 2 is the AI just makes a suggestion, the operator does it. Another is the AI does it and the operator looks at it afterward. And then lastly, it would be the operator, the operator or someone in the plant is just watching the plant performance on a day-by-day perspective, and the AI is doing everything else. That's the levels of AI operation. And so you would go up them, of course, but I think it's important for people to not stop mentally at, we would always have the guardrail of a human reviewing it before it gets sent, because that reality is changing every day.
And look, maybe let me expand a little bit for Andreas. I'll give you a bit of context, right? So you may know this, you may not know this, but I've done a lot of work on the data side, again, when it comes to extracting data and then presenting some of the more traditional dashboards, right? This is a little bit before LLMs came into play, for a fairly large global food and bev company. And what I have seen in the past is that if there's any issues or any mistakes in the data, even though it could be as simple as, the end of the line sensor is not picking up the count of boxes because it's misaligned or what have you, people lose trust in the dashboards and data very quickly. And very often, again, based on my experience, it gets discredited, right? So I also, I would say, like as an OT person, first and foremost, am thinking, how do I spoon feed some of these solutions to upper management so that they see value, but also protect it from them to an extent through the use case of an operator, so that there is some, like fact checking and last line of defense as LLMs get better, as there's less hallucinations, and as we again like prove out that yes, this is better than what we've used to, right? So there is, I guess, some thought in my head and concern that if we go too fast, we can simply burn those bridges, right? And people will lose confidence. That's why, like, I'm also trying to figure out how do I better position, like as you've mentioned, like agents in front of executives in real world scenarios.
Yeah, I mean, that's Caleb said a very interesting point, which, to be honest, I did not yet thought about it, because I always thought, or I'm highly skeptical, let's say, to use LLMs to take over the control, right? Because they are not yet deterministic, yeah, so they can always hallucinate, yeah. But Caleb said, I mean, humans have the same problem, yeah. Maybe the LLMs are getting or having a higher confidentiality, that they are working better than humans, maybe.
Yeah, absolutely. And Caleb mentioned a lot of good points, right? It's
Mhm.
always like the first shift is running better, then you'd ask us to why, right? And it's, well, he tweaks the speed of the machine here a little bit by like 3%, like why? Nobody knows. He's going to push this specific sequence of buttons that nobody truly knows, like why, and he makes some adjustments even on the mechanical side that, of course, are not even captured in the automation space. So yes, there is a lot of, I think, like LLMs and AI in a broader sense understands data a lot better than humans can, right? If I
Mhm.
go ahead, go ahead.
No, I just
Uh,
wanted to add, because
Yep.
currently everyone is using LLMs for everything, because LLM is the way to go, and everyone is talking about LLMs. And yeah, I think maybe not all the time LLMs are the best approach for maybe for controlling a machine. Yeah, maybe you have to use the damn old classic machine learning or so. Maybe that's the better way, because also, as you mentioned, that was also not so obvious to me maybe 1 or 2 years ago, that the operator really has a high impact on a certain domain, yeah, how well the machine performs. That was also sometimes a little bit strange to me, because is it really that operator is adjusting machines in that really sense? It is better working than the other operators doing that. For me, that was not obvious. I thought the machine is, I don't know, programmed and then it runs, and no, there are not so much adjustments anymore. Yeah? But and that I wanted to say, yeah, then it comes to your point, yeah, Vlad. You have to get this data, how the operator has adjusted the machine, to learn out of this. Yeah? And
Yeah, and this
LLMs are
is
typically do not have that. Yeah, you can give them a lot of context, but I think a lot of context in the sense of time series data, I'm not so sure if that is the best thing for LLMs. And then even then, you don't have maybe not an accurate output.
no, of course. And look, this is a slight tangent, I guess, to the main conversation. But ultimately, again, at least in my experience in the verticals that I have been, there is a serious concern about even operator onboarding and training, because a lot of it is going to be more tribal knowledge, right? And they do have a lot of impact on certain parameters. They do have a lot of impact on even like projects or batches, because they have been in the industry for so long. They can make some of those tweaks based on experience, as opposed to how the machine is running, right? And it could be something as simple as a machine running, I don't know, 120 parts per minute. Well, the operator can adjust that maybe by 5% up or down. It's not as obvious that a machine that runs now 125 parts per minute is going to make quality parts, as opposed to one that it's running 120, right? So there's a lot of variables obviously at play. And Caleb, you know this very well. If you throw in the complexity of having even that data collected, analyzing that data, for a human, it is very difficult to process all of those variables at once, as opposed to AI, and I would say more traditionally machine learning, it becomes quite a bit easier. So that's why, again, I'm agreeing with Caleb, right? I'm just trying to be a little bit more cautious when it comes to like deploying some of these solutions a little bit earlier, depending on the customer, of course, and making sure that they are successful and portrayed in the light that they should be, and benchmarked accordingly, right, as to what a human error would be versus what an AI error would be, and that it's not going to be 100% accurate as some would like it to be. But let me bring this back.
I think I think we also have to split this, talking about engineering, and talking about operations,
Yes.
So for the engineering phase, it is totally fine. It's totally super ingenious to use large language models, because with that you save so much time, and there you anyhow you build it, you engineer it, and then you're doing the tests, So
yeah, absolutely, really
but
good
on the
points.
operation side, this is another story.
Let me ask both of you to bring this back to the ProveIt session, right? So ultimately, you had to analyze the data from 1, 2, or 3 factories. Did you find any interesting results, insight? Could you share maybe some of the conclusion as part of looking at the data that was presented by the conference?
To be honest, I can't. I have no clue anymore what kind of data was in. And
Caleb, any interesting insights or thoughts?
Well, I mean, I don't want to comment on the data or anything, just because I don't want it to seem like I'm bagging ProveIt if the data is not perfect or anything. I would say they did a good job on. We focus on the pharma, so I could say is I know that there was a team involved specifically in the pharma use case where it was clear that they understood the pharma vertical very well, and and that helped quite a bit with understanding what was being made and why. I'll stop there. I think that I don't want to get more specific as to kind of the data, just because that is someone's real data, and I don't know what I'm allowed to say before they publish it to the internet, kind of thing.
Gotcha. Okay.
I will make the comment, a couple of comments, but first to Caleb's point on the pharma side. So we had Amy Williams on. We'll go ahead and throw the episode number in the show notes, etc. And she went and built all of the data on the pharma side, and spent a lot of time. Spent a lot of time doing that and going very deep in a couple of directions of that. And so she came on and we did a virtual factory preview show a week or two before ProveIt. It was absolutely fantastic to kind of go behind the scenes and to listen to how she built it and everything along those lines. So you guys should absolutely go ahead and check that out, and shout out to Amy for putting together such a fantastic data set specifically on the pharma side. Having said that, I'm kind of stuck on Caleb's comment from 10 minutes ago in regards.
Sorry to interrupt you. One little comment on that. Not at the data of the last ProveIt, but at the data from the first ProveIt. I had taken a look a little bit more deeper on it, but also not on the on the data itself, but on the data format. I was really surprised to find data which looks like JSON, but in fact it was not JSON. And then sometimes we have some clear raw text and so. And that is also something. Also, again, the good and the bad things of MQTT, data agnostic. You find then unstructured data in there, and that makes also engineering very hard. And that was a little bit of a surprise to me, because I didn't expect to find some, I would not say garbage data, but not well structured data in the broker.
Absolutely. I think we've had several people kind of comment in regards to the structure, and how certainly all structures of data and all data sets are not created equal, both on our end users in real life, and also within the ProveIt broker and ProveIt brokers over the last couple of years as well. Having said that, and my comment was going to be, I'm my brain is kind of stuck on Caleb's comment from just a couple of minutes ago, talking about the use of AI and the need of model and agent orchestration. But specifically, Caleb's comment of how best case scenario, we trust our first shift operator, and very realistically, we don't trust the other two operators in the majority of these shifts. And I'm not sure a more true thing has ever been said on a manufacturing hub. I am not sure that I almost always do I walk into a manufacturing facility and the gripes of management and the gripes of first shift is we spend some not insignificant percentage of our shift resetting from what everyone did yesterday so that we can go attempt to run. And then second and third shift will come in and will make some tweaks, or they'll run out of things, or they'll set things completely outside of parameters. And then first shift comes in again. And especially first shift on a Monday after the weekend crew can certainly be particularly difficult. So I'm not sure I've ever heard a more true statement or a more true statement in relation to going and letting some agents monitor the data. And so I wanted to go call that out and maybe let Caleb comment on that a little bit more. Vlad, I'm not sure Vlad should comment on the non-human within the data set, but I wanted to go call that out because my brain is kind of stuck on it.
No, I mean, I think in life, it's really easy to say no, right? It's really easy to say, no, that will never happen, or that can't happen, or we're not going to do it, or that you shouldn't do it, or whatever, right? So I'm going to, but now I'm going to put forward the following scenario. Do we think, on average, that operators on the floor will be, as time goes on, more or less caring about whether or not the process is going well and having a deep 30 to 40 year understanding inside the facility? We think it's going to be more likely or less likely? If we think it's less likely, then we should ask ourselves what that means is that we already have the problem of entropy on two different facets. Every facility is aging, every machine is aging across the entirety of our supply chain. And we're not building new ones fast. Number two, the workforce is quickly changing generationally. We have more and more likely people who would be more comfortable interacting with an LLM than with a machine directly. That's happening. It's just happening. So, as controls engineers, and I like to say this, as controls engineers, as people who are practitioners in space today, we can do one of two things. We can either kick the can down the road, or we can understand how we would go about doing it, right? Ourselves. Because at the end of the day, the competitiveness of the company that we work for 10 years from now is essentially being made. Those decisions are being made right now, basically. So, and do we think that executives are more or less likely to put pressure to leverage new technology to modernize how we run our facilities, more or less? So and my contention is that you're more likely to see executive pressure, and you're less likely to see operators, employees who can operate, on the floor. Now, this creates a new problem, which I've talked about in my LinkedIn posts, things like that, about what happens when you have a total irrecoverable failure, or what happens when you suck all of the knowledge out of the facility. But at the end of the day, the question is the knowledge being sucked out of the facility implicitly? Right now, the answer is it's happening anyway. So we have to think about how we're going to run our infrastructure. And I even, in the ProveIt session, I even talked about the moral implications of this. From a moral perspective, it is important that we understand how to integrate new technology, whatever that is, in a stable and reliable way with the control systems. I would say that anyone who says just no, who doesn't understand how LMs are evolving, for example, probably should not just be saying no. They should have a reason why they're saying no. They should understand based off of an understanding of the technology and understanding where it's going and understanding of the rate at which it's improving when you would stop saying no, for example, or how you would test over time when it was time. And so from my perspective, it's not enough anymore. Just kind of check out every time the IT team brings up AI, or every time the executives bring up AI or whatever. It's important for controls engineers, in my view, to be thinking about what that looks like. Yeah, we're not good at long-term planning as a species, but we need to get better, because long-term horizon planning is more and more going to be the thing that is actually what we are the best intelligence at. We're not always going to be the best at doing any individual thing, but we do need to get better at long-term planning, because stuff just bites you and everyone says, well, no one could have imagined it would have happened this way. But the truth is that you could have. I'm telling you now that it will. So, that was a rant, but that was
no, I like it. I like it. Honestly, this is the thing that I'm going to ponder for at least the rest of the day, if not the rest of the week, and undoubtedly is a topic of conversation that Vlad and I will have on Wednesday during our normal manufacturing hub. Caleb, Andreas, thank you guys so much. This has been absolutely fantastic. And everyone, thank you guys so much for joining us as we talked about the Siemens and ETM WinCC OA ProveIt presentation. As a recap and as a comment, as soon as the larger Siemens presentation is up, we will go ahead and update show notes, etc., with that information. So you guys can go watch the entirety of the show and the conversation. Big thanks to Siemens for sponsoring this episode and their continued support. If you guys are going to be at Automate Conference, which is at the end of June, Vlad and I will be there. I imagine we'll see Caleb. Andreas, I do not know if you will be in Chicago at the end of June, but you will certainly be able to see us, and we'll be able to go have some conversations. Vlad and I will be in the Siemens booth on Tuesday afternoon is our current plan. So come over, say hi, go ask some hard questions to Caleb, or watch us ask some hard questions to Caleb. Caleb is actively in the process of canceling his reservations for Chicago at the end of June. But no, guys, this has been fantastic. Everyone, thank you for joining us. Please remember to come join and watch the normal Wednesday Manufacturing Hub with Vlad and I. We're talking all about Hanover. We'll talk all about AI. We'll go answer all of your questions and more. If you haven't done it already, please make sure you're following Caleb and Andreas on LinkedIn. Please make sure to connect with Vlad and I and follow Manufacturing Hub. And until, not next week, I suppose until Wednesday, we'll see everyone soon. Thank you.